A warm good evening to all. I am Karthik, Assistant Professor, Mechanical Engineering Department. In continuance of this video lecture, we have first seen about normalizing, hardening process, tempering process, and different types of tempering process with ranges in different temperatures like high temperature, low temperature, and medium temperature. And we have seen about the most important diagrams in heat treatment process, and they are very crucial. And a graphical representation diagram, which is triple T, time temperature transformation diagram, and CCT, continuous cooling transformation diagram, right? So this another one. Here we are going to see about the Jominy End Quench Test. The Jominy Hardenability Test is also known as Jominy End Quench Test. Is a standardized method to determine the hardenability of steel. Hardenability often refers to the ability of a steel alloy to harden in depth under a given set of conditions. The test is essentially for understanding how the material will respond to heat treatment and how deep into the material a hardening effect will be observed. The purpose is that first to assess the hardenability, determine how deep into the steel the hardening effect penetrates under a given quenching condition. Compare to different steel, compare to hardenability of different steel. Third one is quality control, ensures that the steel meets the required specification of the hardenability. Testing procedure, first one is preparation. A cylinder steel sample, typically 25 mm in diameter and 100 mm long, is prepared. So the sample is austenitized, which involves heating into a temperature where it becomes fully austenitizing, usually around 850 degrees Celsius to 900 degrees Celsius, held at a temperature for a specific time required to ensure the uniform temperature and composition. The second one is quenching. Immediately after austenitizing, the sample is placed in a fixture. One end is subject to a controlled water jet, cooling at the end rapidly while the rest of sample cools more slowly. This creates a gradient of cooling rate along the length of a sample, with the end exposed to a water jet cooling the fastest and opposite end the slowest. So in measurement point of view, after the sample has cooled to a room temperature, hardness measurement is taken along the length of the sample at a specific interval, typically every 1.5 millimeter to 1/6 inch, 1.5 meter from the quench end to the other end. So the hardening is usually measured using Rockwell or Vickers hardness scale. When we have the interpretation is that in hardness profile, a graph is plotted with hardness on the vertical axis and the distance from the quench end on the horizontal axis. The resulting hardness profile indicates how hardness changes along the length of the sample. The hardenability curve. The curve shows the material significance hardness penetrates. Steel with high hardenability will maintain high hardness value further from the quench end, indicating the deeper hardness effect. For the factors affecting hardenability, first one is alloying element. Elements such as chromium, manganese, molybdenum, nickel increases the hardenability by slowing down the diffusion rate of carbon and other element during transformation process, allowing the deeper penetration of hardness. The carbon content also affects the hardenability, where the higher carbon content generally increases hardenability. Grain size. In grain size, fine austenitic grain size generally increases hardenability as the more grain boundary acts as a nucleation site for the transformation products. An application of Jominy End Quench Test is first is material selection. Helps engineers select appropriate steel grades for components requiring specific hardening characteristics. Ensure the component will perform the reliability under service conditions. Heat treatment design provides critical data for designing the heat treatment process, such as quenching and tempering, to achieve desired mechanical properties throughout the component. Ensuring the steel produced meet the required specification for hardenability, guaranteeing consistent performance in the final applications. The Jominy End Quench Test is a fundamental tool in metallurgy for assisting ensuring the suitability of steel alloy for various industrial application, helping to predict how a steel will behave during a heat treatment by ensuring the final product meets the product requirements. This Jominy End Quench Test also determines the determine if a chosen steel alloy will achieve the necessary hardness profile after heat treatment by examining the hardness profile obtained from the Jominy End Quench Test. HAS can predict performance of the steel in actual component and makes the informed decisions about alloying composition and heat treatment process. Thank you.